Hello and welcome to my channel.
In a world where the impact of climate change is undeniable, automotive engineers are on a mission to revolutionize the way we approach climate control systems in vehicles. Today, we delve into the cutting-edge technology behind automotive control systems and their role in driving towards a greener future. From the basic manual air conditioning to sophisticated climate control algorithms, we have come a long way. Modern systems not only ensure passengers' comfort but also prioritize energy efficiency. In order to do so, they utilize smart sensors. Smart sensors play a pivotal role in the new climate control era. They continuously monitor ambient condition both inside and outside the vehicle. Our climate control systems are now powered by artificial intelligence and machine learning. They learn from individual preferences, driving patterns, and external factors to optimize temperature and airflow, which allows us to provide zoned climate controls to our passengers. Zoned climate control allows each passenger to personalize their environment. It's just not about comfort, it's about energy efficiency too. Now, when we integrate all these things into one system, it becomes an energy efficient HVAC system. We integrate the advanced material and optimize the design to ensure that our HVAC system consumes minimal energy without compromising the performance. Now let's talk about the components of HVAC systems. First up, we have heating units. To start with, we have radiator heaters. These heaters use hot coolant from the engine to warm up the air. The coolant circulates throughout the radiator and a fan blows the air over the radiator, heating it up before directing it into the cabin. Now, these systems are very power efficient as they use existing engine heat. These systems will generally take a little long because they're using the engine heat to warm up. Now, the second up, we have electric heaters. These heaters use electricity to generate heat. They can include PTC, positive temperature coefficient heaters, resistive heaters, or even electrically heated seats. Now, some of the pros of this system is that they can provide instant heat because they are independent of the engine. The cons of this system is that it places additional load on the electrical system. Now, the third type of heating units that we use today in automotive system is heating cores. A heater core is a small radiator-like device located inside the dashboard. Hot coolant flows through it and a fan blows the air over it to heat the cabin. Now, the pros with this system is that it can be integrated with engine cooling system, but it is very potent to coolant leaks. Now, the next up, we have combustion heaters. These combustion heaters burns fuel to produce heat. This heat is then transferred to the air that is circulated into the cabin. Now, the pros of this type of system is it is independent of the engine and provide heat quickly. And the cons will be because it is independent from engine, they require a separate fuel source, hence increasing the fuel consumption. Now let's talk about the cooling units, keeping things chill in the cabin. In most of the vehicles, it is a part of HVAC system, which refers to heating, ventilation, and air conditioning. The primary components include evaporator, compressor, condenser, and an expansion valve. The process begins with compressor, which pressurizes and circulates a refrigerant. This high pressure hot gas then flows into condenser where it releases heat and becomes cooler high pressure liquid. this liquid passes through the expansion valve where it undergoes rapid pressure drop, turning it into low pressure, cooled liquid. Finally, it enters evaporator, absorbing the heat from the cabin air and turning back into low pressure gas. Then the fan blows the air into the cabin. It is like a magical dance of temperature regulation. We spoke about the heating units and cooling unit of the climate control system. Now let's talk about the air handling units. Air handling units in automotive systems play a crucial role in maintaining the desired air quality and temperature inside a vehicle. These units are responsible for handling air circulation, filtration, and conditioning within the cabin. Now let me break down their key functions for you. The first one is air circulation. AHUs are designed to circulate air throughout the vehicle cabin, ensuring even distribution to all areas. And the second up is filtration. They incorporate air filters to remove dust, pollen, and the other particles from the incoming air, contributing to improved air quality inside the vehicle. Next up is temperature control. Now, AHU regulates the temperature either by heating or cooling the air before it circulates into the cabin. This is often achieved through the combination of heating elements and air conditioning components. The next one is humidity control. Some advanced AHUs have features to control humidity levels within the cabin, enhancing comfort for the occupants. Fresh air intake. Modern AHUs often include systems for introducing fresh air from the outside, preventing buildup of stale air inside the vehicle. Blower fans. A blower fan is a key component of AHU, responsible for moving air throughout the system. The speed of the fan can be adjusted to control airflow and maintain the desired conditions. Also, to improve the energy efficiency, automotive manufacturers are increasingly focusing on making AHUs more energy efficient in order to optimize fuel consumption and reduce environmental impact. Next up, we have sensor integration. Some advanced systems incorporate sensors to monitor air quality and adjust the AHU settings accordingly. This includes sensors for temperature, humidity, and air pollution. Automotive climate control systems use various sensors to monitor and regulate the temperature inside the vehicle. Here are some key sensors commonly found in these systems. Temperature sensor, interior and exterior. These sensors monitor the interior and exterior temperatures. The interior sensors help determine the desired cabin temperature, while the exterior sensor helps the system to adjust for external conditions. Sunlight sensor. Sunlight sensors measure intensity of the sunlight, allowing the system to adjust the air conditioning or heating to compensate for the impact of sunlight on the vehicle's interior temperature. Humidity sensor. Humidity sensor measures the moisture content in the air. This information is used to adjust HVAC systems to maintain optimal comfort. Occupancy sensor. Occupancy sensor detects the number of occupants in the vehicle. This influences the distribution of the airflow to ensure that all passengers experience the desired comfort level. Air quality sensor. Air quality sensor monitors the air quality inside the vehicle and adjusts the ventilation system to improve the air circulation and filter out the pollutants. Evaporator temperature sensor. Evaporator temperature sensor measures the temperature of the evaporator coil. This information is used to prevent the evaporator from freezing and to optimize the efficiency of the air conditioning system. Ambient air temperature sensor. Ambient air temperature sensor monitors the temperature of the air outside the vehicle. This data is used to adjust HVAC systems for varying external conditions. Engine coolant temperature sensor. Engine coolant temperature sensor provide information about the temperature of the engine coolant. This data can be used to adjust HVAC system to ensure optimal engine performance. Blower motor register. Blower motor register, while not exactly a sensor, it is a crucial component in the climate control system. It regulates the speed of blower motor, controlling the airflow into the cabin. All these sensors work together to create comfortable and controlled environment inside the vehicle, taking into account factors such as temperature, sunlight, humidity, and air quality. Now let's talk about the climate control modules. We have different types of climate control modules that are being utilized in today's automotive systems. First up, we have manual climate control. As name suggests, these systems are very basic with manual controls for adjusting temperature, fan speed, and airflow direction. It has no automated features and passengers have to manually select the settings. Next up, we have automatic climate control modules. These modules offers automated temperature control. The system lets the passenger set a desired temperature and the systems adjust fan speed and airflow to maintain it. Then we have dual zone climate control module. This module allows independent temperature control for the driver and the passengers. It is great for accommodating different temperature preferences in the same vehicle. Then we have tri-zone or multiple zone climate control modules. This module allows us to extend independent temperature control for additional zones such as rear seat areas. This is very useful for larger vehicles or SUVs with multiple seating areas. Some of these advanced modules allows us to have heated and ventilated seats. They integrate seat heating and ventilation function to the climate control system and enhances driver and passenger comfort. With advanced modules, automotive industry is also offering defrost and defog functions, which ensures visibility by quickly clearing the condensation or frost on windows, which typically includes front and rear defrost options. Then we have remote climate control modules. These modules allow the driver to preset climate control settings remotely. It is very useful for preconditioning the vehicle before entering. Next up, we have hybrid or electric vehicle climate control, which optimizes climate control to minimize the impact on electric range of the vehicle and may include features like preconditioning while the vehicle is charging. This was all about the different kind of systems and integration into an HVAC system. Now let's talk about some of the recent achievements of automotive systems into climate control. One of which is solar-powered climate control. Solar-powered climate control is a game changer. It harnesses the power of sun to cool or heat the interiors, reducing the reliance on traditional energy sources. As we look to the future, automotive climate control systems are poised to become even more intelligent and sustainable. They will play a crucial role in reducing carbon footprint and creating a more eco-friendly driving experience. From the smart sensors to AI algorithms and renewable energy integration, the automotive industry is steering towards a future where climate control isn't just a convenience. It is a vital component of responsible and sustainable driving.